In this video, we'll look at rational or fractional indices of the form a to the power of 1 on n. In another video, we'll look at rational or fractional indices of the form a to the power of m on n. If you're new to rational or fractional indices, you should watch this video first. A rational number is a number that can be written like a fraction in the form p on q, where p and q are integers. Remember, an integer is a positive or negative whole number, and integers themselves are rational numbers. For example, 2 can be written in the form 2 on 1, 5 can be written 5 on 1, and 10 can be written 10 on 1. Rational indices have a rational number, like p on q, as the index, power, or exponent. For example, 2 to the power of 1/2, 5 to the power of a third, 7 to the power of a quarter, and a to the power of 1 on n are all rational indices. The index laws can be applied not just to integer indices, but to rational indices as well. 5 to the power of a half multiplied by 5 to the power of a half is 5 to the power of a half squared. Using the index law power to another power, retain the base and multiply the powers, we get 5 to the power of 1, which is 5. We know that the square root of 5 squared is 5. Therefore, we infer that 5 to the power of a half equals the square root of 5. The same principle can be applied to any base. Here I've made it a. We have 7 to the power of a third multiplied by 7 to the power of a third multiplied by 7 to the power of a third equals 7 to the power of a third cubed. Using the index law power to another power, we retain the base and multiply the powers, we get 7 to the power of 1, which equals 7. We know that the cube root of 7 cubed is 7. Therefore, we infer that 7 to the power of a third equals the cubed root of 7. Again, the same principle can be applied to any base. Here I've made it a. From this, we can say that a to the power of 1 on n is equal to the nth root of a. Another way we can write the nth root is by using fractional exponents. Here we have the square root of b equals b to the power of k. If we square both sides, the square root of b squared is equal to 1, and we use the power of a power property. We multiply the powers on the right and we get b to the power of 2k. If b to the power of m equals b to the power of n, then m must equal n. So we equate the powers, then divide both sides by 2, and we get k is equal to 1/2. So for all b greater than 1, the square root of b is equal to b to the power of a half. Let's look at some examples. Express the following in index form. We've got the square root of 12. We know from what we've just looked at, this is equal to 12 to the power of a half. We have 5 times the square root of 5. That's equal to 5 times 5 to the power of a half. We know that 5 is equal to 5 to the power of 1. Therefore, we keep the base and we add the powers, and we get 5 to the power of 3 on 2. Now we have the square root of 7 times x to the power of 5. We know that this is 7 times x to the power of 5, all to the power of a half. Now we can bring the power inside the brackets. We have 7 to the power of a half times x to the power of 5 times a half. Let's evaluate some without a calculator. We have 16 to the power of a half. That's equal to the square root of 16. We know that equals 4. Now we have 16 to the power of a quarter. That's equal to the 4th root of 16, and that equals 2. And we have 27 to the power of negative a third. That's equal to 1 on the cubed root of 27. That's going to be equal to 1/3. Thank you.